Bismillahirrahmanirrahim. Today we are going to speak about the basic concept of matrices and algebra of matrices. In this lecture, we are going to speak about the definition of the matrix, equality of two matrices, and addition of matrices. Then we are going to speak about the properties of matrices and also multiplication of two matrices, plus the transpose as co-matrices and symmetric matrices. Let's start with the definition of a matrix. What do we mean by a matrix? So that a matrix is any rectangular array of numbers or functions. It is any array of numbers or functions. Just rectangular array. I would say this is A11, A12, up to A1n. Each one of these numbers is called the element of the matrix. And A11 means the first element in the first row and first column. A12, the second element of the matrix, it is the element in the first row and second column. 2, 1, the second row. 2, 2, up to A2n. M1 up to AM. We say this matrix has M rows and N column, and written by or using the notation M cross N, where M is the number of rows and N is the number of columns. And this is M by N is known as the size of the matrix. Size of the matrix. So we say this is a matrix of size M times N. It means that it has M rows and N columns. And N by 1 matrix is a column matrix. A1, A2, up to AN. It has N rows and 1 column. We call it's called a column vector. Or a column matrix or vector. And 1 by N matrix is or the row matrix. If n equal to n. If the number of rows equal to the number of columns, we say this is a matrix or square matrix. Matrix. Examples. Number one, we say 2, 4, 5, 6, 7, 8. This is a matrix of size 2 by 3. You have 2 rows and 3 columns. Also, it indicates that we have 6 elements in this matrix. 6 entries or 6 elements. The number or the order of the column and the rows is very important to do some operation for the matrix, either for multiplication or for the addition, or also to compare the between two matrices, whether they are equal or not. They must be the same size or number of columns equal to the number of rows in some condition to multiply the two matrices. Number two, this matrix of size is 3 by 3, n equal to m, so this is called a square matrix. This is a square matrix. Later on, we are going to speak about the inverse of matrix, which it must be square in this case. Speak about the equality of two matrices. Of matrices. Two matrices A and B are said to be equal if Aij equal to Bij for each I and j. We say that I sub Ij means we are looking for the element of the matrix A and the elements for the matrix B and looking for the same position of the first element or the element in the first matrix with the same position in the second matrix. We are comparing between the element in the same location or in the same position. First element in A compared to the first element in B. Second element of A compared to the second element of B. If they are equal for each one of these elements, we say they are equal. For example, let A equal to 2, 4, 1, 0, minus 1, 2, 1, 3, and 5. and B 2, 4, 1, 0, minus 1, 2, 1, 3, minus 1. So for that we have these two matrices and we need to check are they equal or not. To check the equality of the two matrices, we have to check every single element in A with the same position in the matrix B. So take the first element, 2 with 2 is okay. We have to compare the element in the same position, same location. 4 with 4 is okay. 1 with 1 is okay. 0 with 0 is okay. Minus 1 and minus 1 is okay. 2 and 2 is okay. 1 with 1 is okay. 3 with 3. 5 with minus 1 is they are not equal. The last element in matrix A is not equal to the last element in the matrix B. So since not all of the elements are equal, we say that A is not equal to B. So the matrix A is not equal to the matrix B because there is one element in A is not equal to the same element in the same position of the matrix B. So this is the idea. Two matrices A and B are said to be equal if every single element equal to every single element in the second matrix, which is in the same position, Ij. Now for the addition of matrices. If A and B are M by N matrices, then their sum is given by A plus B equal to Aij plus A, not A, B plus or Bij. M by N. What's the meaning of this statement? A and B are M by N matrices. It means they must have the same size. They must be of the same size, M by N. If they are not with the same size, then we cannot find their sum. So A and B must be of the same size. And the sum, Aij plus Bij. It means that we are adding the element in the same position. So like we are putting the two matrices over each other and look for the same position of the element and we add them together. And the final answer will be a matrix of the same size, M by N. There is no change in the size of the sum. If we add two matrices with the same sizes, we will have a matrix with the same size. For example, let A be 1, 4, 5, 6, 0, and 2. B equal to 0, minus 7, 9, 8, 1, and 10. The size of the first matrix is 2 rows and 3 columns. The size of the second matrix, also we have 2 rows and 3 columns. So you can see that both of them have the same size. Now we need to find A plus B. Find the sum. A plus B. And to find the sum, we are going to add first element with the first element. So it is 1 plus 0. 1 plus 0 is equal to 1. Second one, 5 with minus 7. 5 minus 7 equal to minus 2. Now 0 plus 9 is equal to 9. So we are adding the elements which are in the same position of the matrices. First element, or the first element in the first row, first column, it was the same, or with the first element in the first row, first column of the second matrix. Second element with the second, third with the third, like this. Now next, I have 4 with 8. 4 plus 8 equal to 12. 6 plus 1 equal to 7. And 2 plus 10 equal to 12. You can see that the size is 2 rows and 3 columns. So this is the idea of adding two matrices. Another one. That we have these two matrices. A is 2, 5, 1, 0, which is size 2 by 2. B, 3, 1, 0, 1, and 2, 7, which is 3 by 2. And we can see that the size of the first matrix is not equal to the size of the second matrix. 2 by 2 and 3 by 2, they are not the same. So in this case, A and B can't be added. Because they are not of the same size. So I cannot add A and B. Third one. Suppose that A is equal to 2, 4, 5, 0, minus 6, 7. B equal to, say, 4, 0, 1, 2, minus 5, and 9. Now the size of the first matrix is 3 by 2. Size of the second one is 2 by 3. 3 by 2 give me 6 elements, and 2 by 3 is 6 elements, but they are not of the same size. These are not equal. First one has 3 rows, 2 columns. The second one, 2 rows and 3 columns. Later on, we will see that for the first matrix A is a system of equation that has 3 equations and 2 variables. But the matrix B, it is like coefficient of a system that has 2 equations and 3 variables. So that these are not equal. So A and B are not of the same size. Also in this case, A and B cannot be added. Let me say 3 by 2 as a size, not as the number of elements is not equal to 2 by 3. This is not multiplication of two numbers. This notation is used to state the size of the matrix. So we can say that 3 by 2 as a size of a matrix is not, or the size is Matrices size. That will give me that A and B cannot be added. So these cannot be added. Now, next point is the scalar multiplication of, or scalar multiple of a matrix. A matrix. Let K be a matrix, or I'm sorry, scalar. So if we multiply K by A, it means that we are going to multiply each element of the matrix A by the constant or by the scalar A. Okay. For example, let A equal to 2, 4, minus 6, 7, 0, 9. Then 2A is multiply each element of the matrix A by 2. It will be 4, 8, minus 12, 14, 0, and 18. Multiply each element of the matrix A by the constant 2 or scalar 2. Let's speak about the properties of matrix addition and scalar multiplication. Multiplication. Suppose that A, B, and C are three matrices. Are M by N matrices. And K1 and K2 are scalars. Then number 1, A plus B equal to B plus A. So this is commutative. The addition of the matrices is commutative. A plus B equal to B plus A. Number 2, A plus B plus C equal to A plus B plus C. What is associative property? Number 3, K1 multiplied by K2 multiplied by A equal to K1 outside and is using the scalar multiplication. Number 3 or number 4, K1 multiplied by A plus B is equal to K1 times A plus K1 times B. Distributive properties. Number 5, K1 multiplied by or plus K2 times A equal to K1A plus K2A. These are some basic properties of the addition of two matrices and the scalar multiplication of matrix.